Dear students, today we are discussing the one of the measure of dispersion called standard deviation. Already we have studied mean deviation, quartile deviation, etc. That are useful for uh, uh, measuring the dispersion. Okay, but the most popular in the sense, in every field, in every application, we can see the use of standard deviation. In every report, in every government report, you can see some mean and standard deviation. So that will give a idea about the dispersion of the observations from the central value. So standard deviation is defined as the square root of the arithmetic mean or square of the deviations of observation from arithmetic mean. So here you can see that the observation is x1, x2, xn, and what is the deviation from the arithmetic mean? Xj minus x bar. Okay, and take the square and add it and divide by n and take the root. So that is it is a measure. It is actually the measure, standard deviation. Okay. When we look at this measure, it seems to be some complicated, but it is very easy to use. Okay, it is easy to calculate. So so this is a measure. So in the case of frequency distribution, that means there are n observations and the corresponding frequencies are f1, f2, etc., fn. Then what is the standard deviation? It's very simple, that is root of summation fj into xj minus x bar square by n. Okay, so this is another formula. Okay, yeah, we can simplify this expression. What is this? Sigma square is, it is usually called variance. In this section it is not mentioned here, but we are usually called this measure, that is square of the standard deviation, that is usually called variance. Okay, so sigma square variance is equal to 1 by n into summation I from 1 to n xi minus x bar square. What is that? 1 by n into summation I from 1 to n, square the term xi minus x bar, that is x square minus 2xi x bar plus x bar square. Take the summation inside. So what will be the result? 1 by n into summation xi square minus 2 x bar. X bar is constant with respect to I. So we will take x bar outside of the summation. Okay. So 2 x bar into 1 by n is also already there. And take the summation for x only. Xi. Actually it is xi. Okay. Plus x bar square into 1 by n. X bar square is here. 1 by n is here. And summation, the remaining term is 1. Okay. So what is the result? Summation xi square by n minus 2x bar into n. What is summation xi by n? That is x bar. Okay, so that is 2x bar into x bar plus x bar square, that equal to summation xi square by n minus x bar square. Right, here we have 2x x bar square and here we have only x bar square, so that will cancel each other. One x bar square will be cancel each other, and the result will be summation xi square by n minus x bar square. So what is the root of this SS, that is standard deviation, root of summation xi square by n minus x bar square. So in a similar fashion or in a similar way, we can simplify the frequency formula. Okay, the simplified version will be root of summation fi xi square. One f will come here. That's only the summation fi xi square by n minus summation fi xi by n all square. Okay, so remember that here in this book we can see it is xi, but there is xi. Here we can see only x, but actually it is xi. Okay, so xi minus x bar square, and I will show you that expression in the book of Fundamentals of Mathematical Statistics. this probability section, and we can see. Yeah, standard deviation sections comes here. Yeah, it is available here. Yeah, this is the standard deviation formula they have used. Sigma is equal to in the case of frequency data. Okay, so it is mentioned that the square of the standard deviation is recorded and is given by sigma square equal to 1 by n summation I from 1 to n fi xi minus x bar square. So s is root of 1 by n summation I from 1 to n fi xi minus sorry, if it is x bar we will call it as standard deviation. If it is a, that means any constant, any arbitrary number, then we will call it as root mean square deviation. Okay. Okay, that much information is given in this section. And you can see so this is if x bar is replaced with a, then that is called as root mean square deviation. So there is some relationship between root mean square deviation and sigma square. Okay, so let us look at that relationship at first. So what is this? S square is equal to, this is root mean square, but actually in that book we have considered S is denoted for standard deviation, but in the book of fundamental analysis it is denoted for root mean square. Okay, anyway, you should remember that difference. So this is this is the formula for frequency distribution, standard deviation formula, that is root of summation fi xi square by n minus n is the total frequency minus summation fi xi by n whole square. Okay, and here we can see the computer to make the computation easy. We will make some shortcut method. So here for a raw data, the standard deviation is defined as root of summation di square by n minus d bar square. Instead of d bar, it is written as summation di by n. Okay, square, where d equal to xi minus a. D equal to xi minus a. Okay. And for a frequency data, you can see that s equal to c into summation root of summation fi di square by n minus summation fi di by n square. So we will look into this expression when we do some problems. Okay, If we consider d like this, in this case we consider d is equal to x minus a, and also we can consider d is equal to x minus a by c. We have divided with a constant c. Okay, a is assumed mean, over c is a class interval, etc. Whatever be the information, a and c are constants. Okay, a can be mean, c can be class interval, or c can be any other value, any other positive value, whatever it is. Okay, you can consider this transformation, that is d equal to x minus a by c. So in that case, we can uh, find the what is that, uh, standard deviation, and it is not given here. I think it will be given in this book. Okay, let us come to that step, the proof later. What will be the I think the second formula is for, yeah, this one for the frequency data. S is equal to c into root of summation f by dA square by n minus summation f by dA by n all square. So where d equal, where d equal x minus a by c. Now we are considering coefficient of standard deviation. So what is the formula for finding coefficient of standard deviation? That is standard deviation divided by arithmetic mean. That means sigma by s or s by s. Here we have used sigma square. The root of this one is called standard deviation. So coefficient of standard deviation is equal to standard deviation by arithmetic mean, that is sigma by x bar, not x, it is x bar. Okay, you should carefully listen my discussion, because there are some errors in this book, but I will explain the correct notation. Listen carefully. Okay, so standard deviation is sigma by x bar. So when you write this formula, you should put x bar here. So this is a typing mistake. Okay, so here we can see some importance of the standard deviation. So you can read, and what is that? Standard deviation is always associated with the mean. Okay, because we have to take the difference from mean. It gives satisfactory information about the effectiveness of the mean as a representative of the data. More is the value of the standard deviation, less is the concentration of the observations about the mean. Okay, I will show that. Galaxy. What is that? I think we have already shown that galaxy picture. That is a This is a galaxy picture. The data are distributed in and around this central value. Okay, in and around central value. If the standard deviation of these observations of the location, or whatever be the observation we are considering, so the standard deviation will be greater than 0 if the observations are spread like this, and standard deviation increases as the spread of observation increases. Okay, so this is not actually statistics, but I would like to show this because to get the idea. Okay, the observations are variated much more. Anyway, we can write the okay. here you can see some data, frequency data. Here the observations are close to central value. At the same time, here the observations are much deviated from the central value, so the standard deviation will be different. For here standard deviation will be less compared to this picture in the above part. Okay, so that is the idea. So we can use the standard deviation as to identify the measures dispersion. Here it is less dispersion, it has less dispersion. At the same time, this data has more deviated from the central value. Okay, according to the definition of standard deviation, it can be negative because it is square. Add the squared observations and then take the what is that, sum, and then divide with n, so it will be always positive. Okay, and moreover, when we take the roots, we will consider only positive roots. Okay, when all the observations are equal, standard deviation is 0. Okay, therefore a small value of S suggests that the observations are very close to each other, and a big value of S suggests that the observations are widely different from each other. Okay, so that is the speciality of this standard deviation. Okay, I think this is sufficient for today's discussion. You can write down this matter in your notebook and Moodle platform. We will discuss the properties after you studying up to this. Okay, after you studying this discussion, we will discuss the properties. Then only you can understand the properties in detail. So you have to study this what is that standard deviation concepts in today's class, and you can write and submit. Okay.